Welcome back to Dr. Han's Pharmacy Classroom Pro. Now, today, let's look at the pathophysiology of portal hypertension. And first, let's review the major blood flow of the liver. There are two inputs of blood flow into the liver. Number one, the hepatic artery, which supplies about one-third of the total blood into the liver. It carries oxygenated blood from the heart. The second blood input is from the portal vein. It carries about two-thirds of the blood supply and is originated from other areas of the GI system, including the esophagus, stomach, small intestine, and most of the large intestine. The two blood supply mix in a void space in the liver called the sinusoid and drain into the central vein. Ultimately, all the blood leaves the liver through the hepatic vein and returns to the general circulation. Now, when we refer to portal hypertension, we are talking about the buildup of pressure in the hepatic portal vein. So, what could be causing the buildup of blood pressure at that location? Let's look at this daily example as an analogy. When you have a clogged sink, there is a lot of resistance in the downflow. So water backs up and fills up in the tank. And the more water you have, the more pressure there will be in the tank. This is the same idea as the portal system. When the liver has pathological fibrosis, such as cirrhosis, the resistance increase, and if the blood flow to the liver remain constant, the blood backs up into the splenic veins, and there will be pressure build up in the portal venous system, leading to portal hypertension. But the story does not end here. High portal venous pressure will trigger splenic veins to dilate to reduce the portal pressure temporarily. However, vasodilation creates lower resistance to forward blood flow into the liver, and the lesser blood flow into the liver causes decreased blood outflow from the liver and decreased venous return. Lesser venous return to the heart decreases cardiac output and lead to systemic hypotension. After the kidney baroreceptors sense the drop in systemic pressure, adrenal glands release aldosterone to activate the renin-angiotensin-aldosterone system, or the RAAS. This impacts fluid and sodium retention and ultimately can lead to cirrhosis-related complications such as esophageal varices and ascites formation.